Dave Locke, I'm co-lead of the PAHO MQTT project along with Andy Piper, who's sitting around somewhere still in here. Andy, where are you? Okay, he's disappeared. So today I'm going to do a talk which is a little different to the ones I normally talk, which are about the bits and bytes and the programming around MQTT. So we've had MQTT, the protocol. It's about 15 years old now, and it's evolved from being a open royalty-free specification through going open source, and now it's becoming a standard. But as we've been doing that, it's been used in a large number of real-world projects in the machine-to-machine, the Internet of Things space. And so what I'm going to primarily do today is to talk about some of those projects, and they range from home hobbyist all the way through to massive-scale commercial projects. And what I found interesting, now it's not jumping, excuse me. Let's see if I can get the... Okay, here we go. This is the first technical problem where it doesn't change the chart on... 2 seconds to take it out of screen share and then redo it. Excellent. We're back and working again. So interestingly, when I put these charts together, there's a whole series across many industries, and I came across a study which just showed what are going to be the big areas around the Internet of Things and connected life. Not going to go into any details, but most of these I'm going to touch on in the talk that we've actually implemented over the last 10 years. The one I didn't think would be at the top, but it actually is around connected car. They reckon that is going to be worth $600 billion by 2020. And then there's a whole range from remote patient care in your homes, assisted living with the elderly, smart home, smart energy, traffic, the whole lot. So I'm not going to go into any details, but you'll see a number of these as I go through that we've got worked examples of. And just for a bit of fun, I suspect most people know what the top two are on here. We've seen them today and heard about them, Raspberry Pis and Arduinos. A few years ago when I put this chart together, lots of people hadn't seen them. But there's a couple of interesting ones on here which I'd just like to talk about because it's one of the trends in the space of Internet of Things. Is a whole bunch of interesting technology, both around open source, the open hardware, like the keynote speeches we heard. But there's some interesting devices, interesting technology coming along. And the two most interesting ones that I like on here, the first one is this little box at the bottom. It's just a light switch, but it's a very interesting light switch. I can go and buy that light switch, take it home, put it on the wall, no wires, and no batteries, yet I can wirelessly turn a light switch on. It's a whole field of energy harvesting. So this light switch generates its power literally by the effect of pressing the switch. It generates enough energy to create a wireless signal to turn the light switch off and on. So there's a whole massive area of research, and this sort of takes it to the nth degree, where you can generate energy from pressing a simple little switch. The other one, which I'll call out, is this one. It's another potentially disruptive technology. So we all know about broadband, and we know about mobile, 3G, 4G, 5G coming along. So this is a type of mobile or networking technology loosely referred to as low-power, wide-area networks. So the idea here is mobile networks still consume lots of power to do the transmission and receipt of data. These networks are designed very much for the Internet of Things space, where you want to get information from inhospitable regions. Maybe in the case of England, we've had lots of flooding, monitoring river estuaries and the environment. So this type of network enables you to communicate typically over up to about a 40-kilometer range from the sensor to the base station, using a small battery collected on the sensor, communicating a sensor reading every 30 seconds, and it will keep doing that for a 10-year lifespan. So it's the sort of numbers we talked about for Zigbee originally, but now this gives us a 40-kilometer range to inhospitable regions with a battery life of about 10 years. So it's quite phenomenal what you can do there. The other benefit of this technology is it's in the low megahertz range, so it can actually penetrate very, very thick walls. So things like energy harvesting, new types of networking are actually going to drive the Internet of Things, drive the billions of devices we're expecting to see out there. So, building on Benjamin's talk, this is a sort of an architectural picture of what we think of as the Internet of Things, and this is what all the examples I'm going to talk about will be based on. So typically in the Internet of Things, you've got a number of things. They might be sensors, actuators, or controllers, which combine sensors and actuators together. Generally, those things do not talk directly to the Internet. They typically talk on a sensor area network to some form of gateway device. There are many, many forms of sensor area network that have existed for many years, plus new ones which are coming now. So typical examples. Home area network, you might use Wi-Fi, you might use Zigbee, Z-Wave, home plug. There are many examples of how you form a network within the home. But then your home gateway bridges to the internet and will use protocols like HTTP or MQTT. The very fast emerging network are around personal area networks. So a personal area network, typically you're using your mobile phone as the gateway device, and the things that talk to it are going to be typically using something like Bluetooth Low Energy. So whether it's Fitbits or your fitness type exercise devices, or the up and coming space that a lot of people are now looking at is around the medical. So basically monitoring people that have some form of sickness and want to be monitored all the time. Within the vehicle, there's been a network in cars for many, many years. It's called CAN bus. And there is a standard way now to get that data out from the car via the onboard diagnostics port. So you can now plug in a little box. In fact, I had one on the last screen. That device just there is a little dongle that you can plug into your car. Any car since 1996. You can pick one of those up for about $7 off eBay. It's Bluetooth enabled. It collects all the diagnostic information live from your car, streams it into your phone, and you can do all sorts of interesting things with the data. You can also do things like resetting service intervals and all sorts of things like that, which cost a lot of money in England. So that's sort of vehicle area networks. There's factory floor networks. There's all sorts of different networks. So generally, these things run autonomously just in case the network to the cloud or to your data center isn't working. The edge gateway then typically is going to talk up to either the traditional enterprise system, or if it's a new system, it's more likely to be based in the cloud on Amazon or somewhere like that. So the data is going to typically come from the devices through the gateway. The gateway typically these days does a bunch of filtering, aggregation, so reducing the amount of data that's going to go across the network. You may even have some application logic on that edge gateway. And as we move into the future, you'll see more logic going on those devices. So we send the data from the gateway into the traditional systems, and it may go into your traditional back-end systems, not so much, but you may find interacting with billing systems, customer relationship management systems. But because of the volume of sensors that are going to be out on the internet in some shape or form, it's driving the whole new world of big data. So this is where Benjamin was saying they're going to look at in the clips about how do we play in there. So we're going to end up with absolutely masses of data, and that's driving the new world of big data and Hadoop and areas like that. And of course, as soon as you've got massive volumes of data, you want to gain knowledge from that data. You want to get either new ways to make new money, and that's where the world of intelligence and analytics comes from. How do we actually deduce important information from that data? And then the final part of the Internet of Things is we've got all the data up there into big data stores and we can analyze it, is once we've analyzed it, or even the raw data, we actually want to be able to visualize that data and get people to interact with that data. And so that's where we end up interacting with either traditional desktop systems or mobile devices. So now you've got examples. One of the examples I give is you might have an intelligent washing machine going forward. The end of the wash cycle sends an event into the cloud. There's an application running in the cloud that looks at the weather and says, it's sunny outside where the washing machine is. What I'll now do is I'll send an event down to the user's mobile phone saying, hey, good time to hang the washing out now. So it's basically, Internet of Things is actually bringing together multiple different types of system, from the raw sensors via gateways into the world of big data, the analytics, and then that interacting with the mobile devices. So now, that's the sort of the overall scene. And I've put the picture of where HTTP and MQTT typically play on the wide area network. Benjamin mentioned MQTT-SN, and protocols like CoAP will also play on the sensor area networks. So now I'm going to talk about a number of real-world solutions. This first one is actually 15 years old. It's pretty much where MQTT started. So one of my colleagues, actually, he's the co-inventor of MQTT, lives in a very old house on the Isle of Wight in the UK. It's a cottage about 15th century. He had a problem with mice. So the talk was talking about rats, but actually it's really mice. So they used to get in all sorts of interesting places within the house that were very hard to reach. So he had to crawl through little attics and eaves to set the mouse traps, and it was very, very inconvenient. So he set himself the challenge of, can I create myself a smart mouse trap that will let me know when there is a mouse in the trap? So he did. So basically, he took a very basic mouse trap, the traditional one, actually the ones that are quite painful if you put your fingers in them, connected up to, actually, this is before the days of Arduinos and devices like that, so he borrowed a device from friends of ours, Arcom system. He basically connected the mousetrap to that little edge gateway box over there via 2 cables, so it basically makes and breaks a connection when the mousetrap goes off. There's some very simple logic on this box that when it basically detects the mousetrap event goes off, it publishes a message. In this case, it was actually to a box that was running on the internet. It publishes an MQTT event saying which trap the mouse has been caught in. And then there's an application sitting very close to the MQTT server, which says when a mouse is caught, or potential mouse is in the trap, it converted it, and this is back in the old days when we had only SMS messaging on phones, we didn't have fancy smartphones. It generated an SMS text message to his mobile phone saying, hey, you might want to go and look at mousetrap in bedroom in the attic. So again, the logic up there is doing some transformation. It's taking the trap number and converting it to something that is English to actually go and look at. So that was actually one of the very, very first MQTT examples. And that was just a pure hobbyist example. And these days, you'd probably use something like Arduinos up here in place of the traditional logic controller that we had up there. So that's a little fun one. And the interesting thing here is, it now turns out, I was at a conference last year, somebody's taken this idea and converted it into a commercial system. So there's a company in the UK called Rent-A-Kill that go around and set lots of rat traps and all sorts of things in all different places. So you can now imagine now they can, from a central site, know when to go and look at mouse traps. They don't have to drive around on a regular basis and check. So very interesting looking at simple little things that people have done for home hobbyists and how that can grow into a commercial system. The same is true of the next one. So this was a project originally in Denmark where basically the farmers need to know when a cow is on heat so they can introduce it to the bull. Or actually, in a lot of cases, they don't really introduce it to a bull. They use artificial insemination these days. But actually, it works both ways. Before these types of solutions came along, the farmers used to actually have to visually watch the cows for certain characteristics to see they were on heat. And they came along and said, look, there's got to be a better way of doing this. There's got to be a way where we can actually, one, improve the accuracy, because it wasn't very accurate, just people falling asleep watching the cows and stuff. So again, the challenge was, can we create a system that basically alerts the farmer when it detects a cow is on heat? So we did this originally using sensors on the cow, using mobile phone technology in the original. That's not the picture I put up here. This is the picture of ones that are actually being implemented and are actually available now. I believe it's in Japan, the company we work with. So what they do here, again, they're using mesh networking technology. So they're using base 802.15.4 as the sensor area network. So there's little sensors on the cows, and the network is formed by the cows, by the sensors on the cows finding the next nearest cow, creating the hop to that cow until they can create the hop from the cow to the gateway box. So now you've basically got a mesh network that goes to a gateway box, and from the gateway box they can publish the events that are used to determine if the cow is on heat. And just for info, there's several ways of determining if there's a cow on heat. One is the amount it moves its neck up and down, how agitated it is. Another one is how frisky, how much it's moving around. So here we're now we're not putting MQTT on the sensors, we're getting raw data across the 802, simple little program into the gateway box. MQTT publishes it across the wide area network to a system in the cloud, and there's some data analysis software which is used to determine when it believes a cow is on heat. Again, like the MQTT, this smart mousetrap example, it then sends an event to the farmer's phone, and he can then go out to the field and either introduce it to Freddie the bull, or use artificial insemination. One of the things I didn't mention there, so of course we get live raw data comes across the mesh network. The gateway box, we're not sending that raw data, and that's one of the comments we heard earlier. We're actually doing aggregation of the data. So multiple data from multiple cows gets aggregated into a single message to optimize the communication across the wide area network into that MQTT server in the cloud. This is one. So building up the type of picture to quite a sophisticated system. So this one, very interesting. Basically, a company we worked with, they make pacemakers and defibrillators. And what used to happen is you used to have to, once you had a pacemaker fitted, go into your local hospital on a regular basis to basically to check that everything is working okay. A little like taking your car into the garage to check that everything's working fine, and then you go home all happy. So the problem with that system is most of the time when you go into the hospital, everything's okay. So you sort of get a bit of peace of mind when you go out. The doctor gets a bit bored because actually there's nothing really for them to do other than to say, yeah, you're okay. So they came to us and said, can we create a smarter system for monitoring people with pacemakers? And so, to cut a long story short, we worked with some partners to create a system. And the way the system works is the pacemakers are intelligent. They have diagnostics data already on those pacemakers. And in the past, when you went into the clinic or the hospital, they waved a magic wand in front of the pacemaker, which read the diagnostic information from that pacemaker. So what we did, we created with them a remote version of that magic wand. So that remote version is that little white box. It sits in your home, typically on your bedside cabinet. So whenever you walk within a close proximity to it, it can collect information from your pacemaker. It then transmits it across the, in this case, a lot of the time it's dial-up networks, because a lot of the people they designed this for were in remote regions in Alaska and places like that. So it's really slow dial-up lines, which is why they used MQTT to do the reliable delivery, into an MQTT server in the enterprise. They know what they expect to see from the pacemaker. So they've got a system now which is just checking the data is expected. If it's not expected, same pattern as before. If there's any sign of abnormality, they alert the doctor or the clinician. And it's then the role of the clinician to say, actually, that's not too bad. We'll keep a close eye on this person. Or no, we need to bring them in immediately. So this one, there is a massive raft of benefits in doing this by creating the remote version of the telemedicine system. So now, the person with a pacemaker gets a 24/7 reassurance. So they're getting peace of mind where they're being monitored pretty much all the time when they're in the home. The doctor, actually, they get big benefits. Now, 99% of the time, they're looking at people where there is a perceived problem. They have to decide what to do and how to solve that problem. So everybody is happy. And as you might guess, the sort of the next version of this, so this has been rolled out since about 2007. It's in about 250,000 homes in Europe and the US. So the next version of this, they're looking at is creating a mobile version. So rather than have a dedicated device in the home, they're looking at can we use something like the smartphone as the gateway? So literally, I'm now walking around and I'm being monitored all of the time. So the pacemaker is just one example. There will be other things you'll be monitored on going forward, which give you this ability to monitor people and detect problems pretty much in real time. And the key with this type of technology going forward is not just detecting problems, it's actually predicting when a problem is going to occur. So get the data, analyze it, and be able to be informed that a problem is likely to occur and do something about it before that problem becomes big. So that is going to be a really big area around the smart healthcare market. Then, building the picture up, we've got the concept of assisted living. So assisted living, basically the observation is the elderly population around the world is growing at a vast rate. That's certainly true in the UK, in the US. We had some folks from Japan over at our lab recently. It's a big problem in Japan and in China. So the question is, so the problem, first of all, is it's very expensive to care for the elderly when they start going into homes or even in ward and assisted living. The care costs are very, very expensive. They're getting to the point where with the number of elderly, it's just not feasible to manage that number of people in the way we typically do them. So the challenge is, how do we create a modern way to care for the elderly so that they can stay in their own homes for longer, they get peace of mind that they're being monitored and there'll be immediate interaction if there is a problem. Their families can get peace of mind because they can see what's going on. So the idea, again, how do we basically keep people in their homes for longer? So there's a number of people working on this type of project. Very similar concepts to the other one. We basically instrument the homes with a bunch of sensors and the elderly with sensors. Different elderly have different problems, so we use different types of sensors out there. So we've got different sensors from where is the person, the sensors that they carry around so they can determine if the person has fallen over with the button to say, help, I've fallen over, or actually, so they don't even press the button, it determines the person's fallen over and sends an alert immediately. Sensors in the home, like on the stairs, you put pressure sensors at the bottom of the stairs and the top of the stairs, so you can determine once someone goes on the stairs, do they reach the top of the stairs in a certain amount of time. Energy monitoring, temperature, motion, so all sorts of sensors. And what it turns out is, as you get older, you become more and more creatures of habit. So you typically get out of bed at the same time, put the kettle on the same time. So you can basically model how a user expects to be within their home. So you can detect trends and determine when they're not following that pattern. That might be a sign that something isn't quite right. You can use other events like the falling over event, or they haven't reached the top of the stairs in a certain amount of time. There's more and more medical devices that help you interact with the user. So there are now smart medicine boxes that basically determine when you've taken tablets out of the box or not. So again, you can interact with boxes, smart medicine boxes. So if you can actually get all of this data up into a data center, you can analyze it. Again, similar concept to the past. You put in the analytics in there to say, actually, is everything okay with the elderly? As soon as there's a problem with them, then you actually want to investigate it. So you might call them up first of all, and if you don't get a response that everything's okay, then you dispatch a mobile warden. So rather than having fixed wardens that basically sit in the homes and control 10 houses, I can now have a small number of wardens that cover a very wide area. So in this case, what they did, they basically determined there's a potential problem. They look up. This is the system doing it, actually looking at where the nearest warden is based on their GPS location. They immediately feed live information to the warden's mobile phone, so he knows before he gets anywhere near that home exactly what to expect when he goes in there. The same is true for the family. The family can get remote access and to the person's home, so again, they can get peace of mind. You've got the control room with a big dashboard, basically like a local city control room for the elderly. And again, not introduced in this one, but the idea is that you introduce telemedicine so that if there is a possible problem, health problem, they can interact directly with the local doctor. So very interesting project. Again, same type of pattern. You get the raw data goes into the gateway. That data is aggregated, sent across to in this case, it is a cloud server where we run the analytics close to that system. It then feeds either the warden's mobile device, pushing information in live to the device using MQTT, big dashboards in the control room screen, and also providing remote access for the family of the elderly. Then the next one is sort of building the picture up again. So the Internet of Things is really about breaking out of silos. So silos where maybe only a department can get a certain amount of data, or maybe you've now extended it so the entire company can interact with the things. But actually, the Internet of Things is truly about enabling multiple different companies and multiple different use cases to interact with the same data, the same devices. This is sort of starting to get there. So this is a solution that combines the concept of smart home, which is sort of what assisted living is. Assisted living is smart home, but with a particular slant towards looking after the elderly, and smart energy. So again, certainly in the UK, we're running out of energy generating capability. We don't have enough power stations. In fact, we're taking them offline because they're not green. And for a number of years, I know in the States, you haven't had enough energy generating capability. And often you get problems where you do a brownout when you determine a problem's going to occur, so they lower the voltage for a period of time and then raise it back up again, or you get a power cut. So one of the ways that people are starting to think about this in its very early stages in most countries is using smart metering to start electronically connecting the home to the energy control systems. And actually, in most cases that I've seen around the world, they're only using it in a very simplistic form. So they're putting smart meters in homes, they're sending an electronic meter reading to a data center, and they're going to give you an accurate electricity bill or gas bill, whatever you're monitoring. That's what's happening in the UK. They're not actually going to do anything else with that data. So it's a little bit boring. They save money because they don't have someone going around reading the meters. But actually, as soon as you get connectivity from the home, you can do so much more with that. And the company that put this in place jumped several generations of smart metering. And they've created a system that combines smart home and smart energy together. So what they do here, they basically instrument the home, very much like the assisted living one. In this case, they're using Zigbee within the home for wireless communication and home plug for devices for doing communication around the mains wiring within the home. They put in an intelligent smart meter. That meter acts as the gateway from the home to the outside world. They put in intelligent heating, ventilation, and air conditioning systems so they can read the temperature, they can control it remotely. They instrument devices which consume lots of energy, so things like fridge freezers and swimming pool pumps and things like that. They enable control of heavy hitting devices like swimming pool pumps. So within the home, basically, they now can monitor and control a large number of devices, not just reading the overall energy. They get that data, they use MQTT to send that information to their system in the sky, what they refer to as their virtual power plant. So now, about every 5 minutes from every home, they're getting information about individual appliance usage, how much the overall home is using. They're getting information about temperature and humidity in the home, i.e. all the things which are going to affect potentially energy demand going forward. Their virtual power plant analytics application then takes additional data feeds. So it's going to take feeds from things like the futures market. They know how much energy they've already paid for in the futures market. And what they don't want to do is buy energy on the spot market. So they only want to use what they've already paid for in the futures market. The one thing if it really push comes to shove, they will buy energy on the spot market. The thing they really don't want to do is run out of energy at all, because that then involves you having a brownout or a power cut. So basically, they're taking information which is going from the home, which is live information, weather forecast, so they know if it's going to get colder, people are going to turn the heating up, or vice versa with the air conditioning, how much energy there is out there, demand trends, so they know at the end of certain programs, people are going to put the kettles on and drive demands up. So the idea is the virtual power plant application now takes all of that information, munges it together, and if they get near any of the thresholds, like I'm going to run out of energy or I'm going to have to buy new energy on the spot market, they say, actually, we need to prevent that. We need to shed load on the grid. So they pick about 10% of the homes, and they say, okay, home number 1, lower your temperature by a couple of degrees for the next 15 minutes. Home number 2, turn your swimming pool pump off, et cetera, et cetera. So it's a unique command to every home. So they send these commands out. They're immediately getting feedback from the individual homes. If they don't get enough energy load shed, then they pick another percentage of the homes, send out unique commands to that, till they get the desired effect. The really clever thing about this system, well, there's 2 parts. First of all, most people don't like the idea of somebody outside of their home controlling their home. So it's a bit like Big Brother. Somebody can come in and turn their heating on or off or do monitoring of their homes. So they have to be able to get buy-in of the homeowner. So the way they do that actually is, well, it's probably not surprising, it comes down to how much you pay for your bill. So when you sign up to this system, you say how much control you're going to let the virtual power plant have of your home. So I might let them control my temperature and lower it by a degree for maybe an hour. Other people may allow more control. So depending how much control you have, depends on how much the price you will get charged. So basically, the more control you give them, the lower your bill is going to be. The other thing the way you get buy-in is most of the time when they're using this system, you have no clue that they're even changing anything in your home. Because typically they're only going to lower the temperature in your home for about 15 minutes. You won't even notice that. They might turn off the swimming pool pump for a short period of time, and it will then come back on at another point in time. The way this system works is, it's basically a little change in many, many homes that cumulatively adds up to a big overall impact on the overall usage of the grid. Now, so that actually gets big savings, smooths out the usage of the grid, so it's a very nice green solution. But actually, the company that produced this got additional benefits because now they may have bought more energy than they need on the futures market. They can also do interesting things, like they can sell energy back on the spot market. So when they know there's excess energy and they know nobody's going to use it or they're not going to do it, they can actually sell energy back and make money themselves. So some interesting business models when you start doing this. But it's a bit like assisted living with this one. When these solutions get implemented, you have to think about the psychology of the end users. The assisted living one, originally thought about putting webcams in the elderly's home. And anyone they talked to just balked at that. Again, big brother. But the elderly really didn't mind having passive sensors monitoring energy, monitoring for water on the floor, monitoring for motion. They had no problem with that. Webcams they did. Same with this one. You've got to put it across in the right way to sell it to the home users. Oh, and this is just, so we're talking about architectural patterns. They all use MQTT predominantly for the solution here, and this is just the suggested MQTT topic space. So MQTT being a publish-subscribe protocol enables you to send one event in, and then 0, 1, or more users can express an interest in that topic. So we came up with, this was the sample topic space we actually gave the company that implemented this, which basically had its hierarchical topic space where it starts with country, region, town, postcode, unique house, and then within the house, you've got things like energy consumption, solar, alarm, so security state, temperature, etc. So having a topic structure like that enables multiple different ways to interact and decide which data you want. So there's some examples down the bottom here. So I can subscribe for data just from a particular house. So I'm going to subscribe for a particular house in Hursley, house number 1 in postcode SO21 2JN. And in this case, I will only receive the energy consumption information from that house. Now, I can also say, give me the energy consumption information from all houses in Hursley. So we've put wildcards in here, plus. Or we can do a very wild card which says not just the energy consumption, but give me every bit of information comes from all the houses in the SO21 2JM postcode. So with MQTT, it gives you a very nice way to decide and express your interest in particular sets of data. And then the last chart I've got sort of brings it together. I said connected car is actually likely to be one of the biggest revenue earners and services opportunities going forward. And this one sort of brings together the concept truly of the Internet of Things. So now, if I can connect the car up to the internet, it opens up a whole raft of possibilities. Now, most people are thinking about it in silos at the moment, but the true Internet of Things, as I said earlier, is about opening up to many opportunities. So who's interested in the data coming from a car? The automotive manufacturers are really interested in getting that data because they can now start doing predictive analytics. They can get the data from the car, they can help get that information and determine when problems are going to occur before they occur. They can send messages directly to the car saying, get your car into the garage, otherwise you're going to get a very expensive bill. If you get it in now, it'll be much cheaper. They can recall just the cars that need recalling. Rather than recalling every single car, they can recall just the cars that maybe have a bad batch of components. Insurance companies would love to get their hands on that data. So insurance companies, again, trend, very expensive insurance for youngsters. So we did projects 10 years ago, and they're now coming up across the world. What happens if we can actually determine if you're a good driver versus a bad driver? So if we can get information about your driving habits, the insurance company can now do pay-as-you-drive insurance, where they determine the price of your insurance policy based on your driving habits. And they're even now gamifying it, so they make you compete against your fellow drivers to see who's the best driver. So it's another interesting way to actually turn some of these things on their head. The transportation systems, the smarter city, the parking systems would love to be able to get interaction with this type of data. So now you can imagine, I set my sat-nav from the home, so the homeowner sitting in the home sets where they want to go. Maybe I want to go into London to see a show. So I basically program from the comfort of my home, from the sofa, I'm going into London, I want to park roughly in this vicinity. That gets sent across via the cloud into the car, personalize the car before I get in there. Get in the car, everything's set, start driving following the satellite navigation system. One of the biggest problems we have today in big cities is you often go to near where the car park is and you drive round a dozen times before you find a parking space. Wouldn't it be quite neat if the car parks actually could publish information which says, oh, there's 5 parking spaces available at this one, there's 100 in this one. So actually, as the car gets near to the location where you're trying to get to, it says, oh, I will find the car park that's going to give me the best chance of finding a parking space. So it's, again, bringing together lots of data. So really, once you put that connectivity in place, it becomes the plumbing. So we tend not to think about plumbing in our houses or our sewers, but without plumbing and without sewers, our civilized society wouldn't exist. So the Internet of Things is about putting in place the plumbing and the sewers, and that's the raw connectivity. It's then about, once you've got that raw connectivity in place, what do you do with it? And most people these days are thinking in a very blinkered approach. What this is suggesting is if you actually widen the scope and say, actually, I can get that data to anyone that is of interest to it, it opens up a massive, massive realm of possibility. I'll leave the thought with you. It opens up some interesting questions. Who owns the data? The automotive manufacturers would love to own the data and then sell it to other people. The same with the insurance companies. But actually, it's your car. Shouldn't you own the data and then decide who the data goes to? So there's actually, with the Internet of Things, there's going to be some big tensions between big business and how you might want to use that data. So some interesting discussions over a beer around that subject, and it's going to be very interesting to see how things evolve. So I'll leave it there. That's been a rapid sort of whistle-stop tour of a number of different Internet of Things solutions, but sort of gives you an idea of the art of the possible, of systems that have been put in place over the last 15 years. And after seeing some of the things this morning about the digital fabrication and stuff like that, I think we're in for some very, very, very interesting times with what we can do with the Internet of Things and digital fabrication and everything all combined together. So thank you very much. More than happy to take questions.